Hey, today we're going to look at a little bit more right triangle trig and other angle relationships in trigonometry. So from geometry, you probably remember angles of elevation. Angle of elevation is from the horizontal up to the line of sight of the object. For angle of depression, it's from the horizontal down to the line of sight to the object. The angle of depression and the angle of elevation are actually going to be congruent to each other. And here's why. So here we have these two horizontal lines, right? Every horizontal line is going to be parallel to every other horizontal line since they each have the slope of 0, right? So then that line of sight right there that crosses my parallel lines, that's like a transversal in geometry. So this angle and this angle are alternate interior angles, and when lines are parallel, alternate interior angles are congruent. Cool. What I tend to do also, though, is I make this guy into a rectangle, and then I use opposite sides congruent, things like that. Okay, so let's try a problem. The distance between the base of a tree and a point of observation is 4.2 meters. The angle of elevation from that point to the top of the tree is 38 degrees. What is the height of the tree? So first of all, we have a tree. And then there is a point that is 4.2 meters away. From that horizontal up to the top of the tree, they tell me is 38 degrees. And we want to know, what's the height of the tree? So we got that 38 degrees. We'll start labeling up our sides. Across from this is my opposite side. Across from my right angle is the hypotenuse. The side that's left over is the adjacent. Since I want to find my opposite and I'm given adjacent, I need to use tangent to solve. So we have tangent of our angle is 38 equals opposite over adjacent, so x over 4.2. And to solve for x, we'll multiply by 4.2 on both sides. And then when we pop that into our calculator, being careful to be in degree mode, we're going to end up with 3.28 meters. Okay, good deal. From the top of a 188 meter high cliff, the angle of depression to a boat in the bay is 13 degrees. Find the distance from the boat to the top of the cliff. Okay, so we have a cliff. And here is the top of it. And we know it's 188 meters high. From the horizontal, so here's my horizontal line, down to a boat in the bay, so here's my boat. From the horizontal down is 13 degrees. Find the distance from the boat to the top of the cliff. So right here is the distance from the boat to the top of the cliff to that dude, right? Okay. So here's what I tend to do. I go ahead and turn the picture that I just made into a rectangle. I know that in a rectangle, I have right angles. And I also know that opposite sides are congruent. So now I have this triangle with an opposite side of 188 and a hypotenuse of x. Cool. So since I have opposite and hypotenuse, that means I'm going to use sine. So sine of my angle is 13 equals opposite over hypotenuse, so 188 over x. Either you're going to multiply by x on both sides and then divide by the sine of 13. You can cross multiply. You might have been told when you were a kid to switch the trig and the x when x is in the denominator. However you want to solve that problem makes me happy. So I have 188 divided by the sine of 13. And then when we pop that into our calculator, we're going to end up with a distance of 835.7, and that's in meters. Cool. So those are things you learned in geometry. The next things are going to be, you might have learned them in Algebra 2, but I think that all of this stuff started coming right when pandemic happened, so you might have missed a little bit of this. So coterminal angles. They are angles who share the same initial and terminal sides. Basically, if we go around the circle again, we're going to end up at the same spot. Or if we go reverse in the circle, we're going to end up in the same spot. So to find coterminal angles, you're going to add or subtract 360 or 2 pi, depending on whether you're in degrees or radians. Make sure you always stay in whatever units you are given, okay? If you are given radians, you need to stay in radians. Cool. Then there are reference angles. Reference angles are positive acute angles that represent angles of other measures. It's the smallest angle made with the terminal side and the x-axis. Now, I know this is going to feel strange, but to me, when I think of reference angles, I think of chickens because they flap their wings, right? So here's my x-axis. Either my terminal side is up above that x-axis, so my reference angle is going to be down to the x-axis, or my angle is below the x-axis, so my reference angle is going to be up to my x-axis. So reference angles make me think of chickens. Doesn't matter, just throwing it out there. Okay, so first we are going to look at coterminal angles. So remember, coterminal angles begin and end in the same spots. So right here we have 317 degrees. So if we think about this as a picture, remember our angle starts right here. That's where 0 degrees is. There's 180, there's 170, and a little bit past that. And then over here is another 360 degrees. So to get a positive coterminal angle, I could go around this circle one more time and end up at the same spot. So I can take 317 plus 360, for my positive coterminal angle. That'll be 677 degrees. Or we could go the other way from 0 down to meet that angle, so going in the negative direction. So if we take 317 but subtract 360 this time, we're going to end up with negative 43 degrees. So each of those angles is going to land in that same spot. Cool. In this next one, we have 3 pi over 8. So let's think of 3 over 8. 3 over 8 is a little less than a half, right? So let's draw a picture. So 3 over 8 is a little less than a half. So that means I'm a little bit less than pi over 2. Pi over 2 is right here. So I know this is going to land somewhere in this area. So I could keep on going around the circle. Do one full revolution and match up at the same spot. I'm going to have to take 3 pi over 8. And then I want to add 2 pi to it, right? Well, let's rewrite this 2 pi in terms of eighths. So 2 pi is the same thing as 16 pi over 8. If I take 3 pi over 8 plus 16 pi over 8, I'm going to end up with 19 pi over 8. So there's my positive coterminal angle. I could also go the other direction to end up at this angle, or that terminal side. We would take that 3 pi over 8 and subtract 2 pi from it. And this time 2 pi is going to look like 16 pi over 8. 3 pi over 8 minus 16 pi over 8 is going to give me negative 13 pi over 8. So there is my negative coterminal angle. Go ahead and try those last two on your own. Okay, so on 177 you added 360 to get 537 degrees, and you also subtracted 360 to get negative 183 degrees for coterminal angles. Over on this next one, we had pi over 5, so we added 2 pi, this time disguised as 10 pi over 5. So my positive coterminal angle is going to be 11 pi over 5. When we subtract 2 pi, we end up with negative 9 pi over 5. Now we're going to take a look at reference angles. So please stay within the given units. Please, 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 please. So reference angle, they're like chickens. Here we go. Let's draw a little picture first. 155 degrees. So 155 is more than 90, but less than 180, right? Oh, just as a reminder, here's 0 degrees, here's 90 degrees, here's 180 degrees, here's 270 degrees, and then back over here is 360. So that means 155, it's between 90 and 180, so it's going to be somewhere in this direction. Since reference angles, it's always how far until the x-axis. We're either going to go down or up to our x-axis. So we're asking how much is this angle right here? Well, I know that that full angle from 0 over here is 180 degrees, right? So if I take 180 and I subtract out 55, I'm going to end up with 25 for this angle right here, right? So that means that my reference angle is 25 degrees. It's positive and it's acute, and it's made with the x-axis. Cool, now let's look at the 35 degrees. So 35 degrees is less than 90 degrees. So he's going to be somewhere in here. Now what you might notice is that 35 degrees is already positive, acute, and is the angle formed with the x-axis, right? So 35 degrees is its own reference angle. It's 35 degrees. Now let's look at 472. Now 472 is more than once around the circle, right? So looking at a coterminal angle could be super duper helpful for us. So coterminal is when we're going to add and subtract 360. So in this case, to get it to an angle that we recognize, we want to take this number and subtract 360. So 472 minus 360. That's going to leave me with 112 degrees. So now, basically, I'm finding the reference angle for 112 degrees. So 112 is between 90 and 180, so that means it's going to be somewhere over here. So from here to here is 112 degrees. How much more for that angle made with my x-axis? Well, if we take 180 minus 112, we're going to end up with 68. So my reference angle is 68 degrees. It's positive, it's acute, it's made with the x-axis. Cool. Now let's look at some stuff with radians in there. So just as a reminder, This is 0 pi. Up here is pi over 2, or half of a pi. Over here is pi. This is 3 pi over 2, or 1.5 pies. And then we have 2 pi over here. Same spot. Okay, so 4 pi over 7. Is 4 over 7 bigger than a half or smaller than a half? He's bigger than a half, right? So I know that 4 pi over 7 is going somewhere over here. 4 pi over 7. So we want to know how much more to reach my x-axis, because I want this angle right here. Well, I know that on that axis I have pi over there, right? Let's think of pi as 7 pi over 7. Well, if I have 7 pi over 7, I already have that 4 pi over 7. How much do I have to add to 4 pi over 7 to get 7 pi over 7? 3 pi over 7. So my reference angle is going to be 3 pi over 7. On this next one, we got 0. Right here is pi over 2, or half of a pi. Over here is 1 pi. Down here is 3 pi over 2, or 1.5 pies. And this is the same thing as 2 pi. So 9 pi over 8. 9 over 8 is a little bit bigger than 1, right? So it's a little bit bigger than 1 pi. So I'm going to be a little bit bigger than 1 pi. So this is 9 pi over 8. Now in this case, remember I'm always going back up to my x-axis. I'm trying to figure out how far over pi did I go? What's that angle measure that I went past my x-axis? So I'm going to think of pi as 8 pi over 8. How far over 8 pi over 8 did 9 pi over 8 go? A pi over 8. So my reference angle on this one is pi over 8. Okay, I would love for you to try those next 4 on your own. So we got 202, negative 183, 7 pi over 4, and 17 pi over 5. Find the reference angles for all 4 of those, please. Okay, so on this first one, our reference angle is going to be 22 degrees because from 0 to 180, and then we went over that x-axis by 22 degrees. Over here with negative 183, so we're going in the reverse direction this time, and we go just a smidge past negative 180, so we're ending up in that second quadrant over there. We went 3 degrees over 180, so that means that reference angle is 3 degrees. Over here, 7/4, that's not quite 2 pi, 8/4, so we know it's going to be over here in this fourth quadrant. How much did I need to make 8 pi over 4, or 2 pi? I just needed 1 more pi over 4, right? So that's why that's my reference angle. Over here, 17 pi over 5, that's the same thing as 7 pi over 5 if we subtract 2 pi to get that coterminal angle, right? And then right there at pi, we have 5 pi over 5. How much over 5 pi over 5 did 7 pi over 5 go? 2 pi over 5. So that's why that's my reference angle. Okay, see you guys later.